Okay, there are three really big concepts that we're going to go over today, and so I'm going to just jump right into this lesson. We're going to go over the equation of a line, what you need to make an equation of a line, and then we're going to go over rational denominators and also completing the square. So really, really a lot of important information, three different big topics. But first of all, das a foot, das, das a knee. Okay. All right, let's jump right in. Let's talk about the equation of a line. We're going to start with a horizontal line. So look at the horizontal line in this graph. Okay, remember horizon is like, like a horizon. It's going to go left to right across the graph. A horizontal line does not ever cross this x-axis. Okay, it's either going to be, I guess it could be right on it, but it's either above it or below it. But it's going to cross the y-axis. The y-axis is this one, and it's going to cross it at only one point, and that point is called the y-intercept. One other thing about horizontal lines is that what is the slope of a horizontal line? A horizontal line has a slope of 0. Is that what you guessed? If you said 0, you got it right. So there's no tilt to it. It's not tilting up or tilting down. It's not slanting in any direction. The slope is 0. Okay, back to the y-intercept. The y-intercept is where it crosses that y-axis. It's only going to do it at one point, and it's going to be right here on this particular line, which is the coordinates of 0 for x, 4 for y. So remember the coordinates are x, comma, y, and that particular point is going to be 0, comma, 4. Okay. The equation for this line, whenever you have a horizontal line, is just going to be y is equal to some number. In this example, it's y is equal to 4. Let's see why that makes sense. Remember, for every point on the line, you have an x and you have a y, and it's written like this. When you have a horizontal line, the x, it doesn't matter what it is. It could be anything. It could be 0, it could be 1, it could be -1, it could be anything. It's going to be some x, and the y is always going to be 4 for this particular line. And you can see how if you are going to plot that, you could do 0, 4, or you could go on the graph and you could go over 2 and then up 4. The y is always going to be 4, and that's why you get this line. And so the equation for any horizontal line is just y is equal to some number. If y would have been -2, the line would have been like that. Okay, cool. All right, what about a vertical line? A vertical line has a slope that is straight up and down. Think of vertical like this, like the V is pointing down. It's like an arrow pointing down like that, or it could be going up, whatever, it's up and down. The slope of any vertical line is actually undefined. Undefined, so it's not 0, it's undefined. It's just straight up and down. That's what it is. Okay, this type of line never crosses the y-axis, actually, I guess, unless it's directly over it. But it does cross the x-axis, and it crosses it at one particular point, and that's going to be the x-intercept. And in this situation, it happens to be 0, -2, right there. The equation for a vertical line is always going to be x is equal to something. In this case, x is equal to -2. Let's look at why that makes sense. Remember that anytime you plot a point, you've got an x, comma, y. Now, whenever you're plotting points on this particular line, you're going to start with the x, which is always going to be -2, and then the y can be anything. The y says how far up and down you go, right? -2, -4, and it's always going to land somewhere on this line. Okay, perfect. Let's move on. What about a regular line that's not horizontal or not vertical? Just a line, going like this. A straight line. It has to be a straight line. Now, every line is going to have a slope, which is m. We're going to get to that. And a y-intercept, which is b. We're going to get to that. All you need to know are those two things. You need to know the slope of a line and the y-intercept. Then you know everything about that line. You know where it's going, what its future is. You know where it's been. All you need to know are those two things, and you know everything there is to know about a line. Okay, here is the slope-intercept form. So when you're writing the equation of a line, this is the standard form that you're going to write it in, y is equal to mx plus b. You might remember we've covered that in the past. M is the slope and b is the y-intercept. X and y are just any random points on the line, right? It could be 0 for x and -2 for y. It could be anything, right? All right, let's look at some of these slopes. Remember that positive slopes go uphill. It's positive to go uphill because you learn something from it, right? If it's going downhill, it is a negative slope. All right, a little Thor for you to look at since we've been watching that Chris Hemsley's show. That's his name, right? I don't know. We've been watching that show and just thought you might want to see his acting, I guess. All right, let's do example 10.1. Find the slope-intercept form of the equation of the line that passes through these points, -3, 2, and 4, -3. Woo, okay, so they gave us a couple points. They gave us these 2 points that are on a line. All you need is 2 points of a line, right? And you can figure it all out. So they want us to write an equation for the line that goes through those points. What 2 things do we need to know about a line? The first thing is we need to know its slope. So let's figure that out. How are we going to figure that out? Let's graph these points that they give us. They give us -3, 2. So let's start with that one. We're going to start with 0. Okay, remember, you make a graph like this. This is the x, this is the y. The y goes up and down. All right, so we're going to graph the point -3, 2 first. This is the x, this is the y. So on the x, let's go to -3. 1, 2, 3. On the y, let's go to 2. 1, 2. Okay, so our point is going to be right here. Sweet, we got that. What's the next point? The next point is 4, -3. Remember, you've got your x, you've got your y. Let's go 4 on the x first. Ready? Let's go. 1, 2, 3, 4, and then -3. 1, 2, 3. Okay, now we can draw our line. And luckily this program fixes it for me. All right, now we've got the line. Now, the next thing we're going to do with this line is we're going to draw a right triangle. I'm just going to bring this down. Oops, I went too far. That's all right. All right, there's my right triangle. Why did I draw a right triangle? Because I remember that the slope of the line is rise over run. And this is going to help me. How much do I rise when I go from this point to this point? Because I know those 2 points are on the line. So that'll help me figure out the slope. The rise is this part. So let's count the squares. 1, 2, 3, 4, 5. The rise is 5. What about the run? 1, 2, 3, 4, 5, 6, 7. 5 over 7 is my slope. Now don't forget the sign of the slope. Is this a slope of positive 5 over 7? No, because if I put a little car here, he's going downhill. So it's -5 over 7. Okay, what's the next step? The next step is I need the y-intercept. I need where it crosses the y-axis. If you kind of look at this, you can estimate, but that's not going to make it perfect. So the proper way to do it is to write the equation with what we know so far. So I want it to look like this, y equals mx plus b. So far I have y equals -5/7 x plus b, and I'm looking for b. What is that? But the other piece of information that they gave me were those 2 points. So I know that I can plug those points in for an x and for a y, and then I can solve for b, and then I will get b perfectly. So that's what I'm going to do, and it doesn't matter which points that I use. I could use -3, 2, they gave me that. I could also use 4, -3. I just put 1 in for x, 1 in for y. So let's go with the first point that they gave me, which is -3, 2. All right, so this is x, y. So I'm going to put -3 in instead of this x, -3. Then I'm going to put in 2 in place of the y. And then all I do is I do the math and I solve for b. And when I do that, I get b is equal to -1/7. So that is all I need to know. For the equation, you need the slope and the y-intercept. So let's write the equation now. Y equals mx plus b. Instead of m, I'm going to write -5/7. Whoops, -5/7. And instead of b, I'm going to write -1/7. I'm just going to change that plus to a minus. And this is my final answer. That's the equation of the line. Y equals -5/7, x minus 1/7. Woo, that was fun. All right, let's do another one. Let's do example 10.2. Find the equation of the line that passes through this point. Now they give us 1 point, and it's perpendicular to this line. So they give us another equation for a different line, and they tell us this line is perpendicular to the line that we want. Okay, what does this tell us when it's perpendicular? We can figure out the slope from that. But first thing, we have to get this into standard y-intercept form. Y equals mx plus b. So we just have to rearrange it and solve for y. So if I do that, I'm going to get y is equal to -4x plus 2. Divide everything by 3. Then I get y is equal to -4/3 x plus 2/3. I just basically divided each term by 3. So the slope of this line is -4/3, but that's perpendicular to the line we want. Now you have to know another piece of information, which I'm going to tell you now. If you have a parallel line, the slope would be the same. But if it's perpendicular, the slope is a reciprocal, and it's the opposite reciprocal. So it's a negative reciprocal. So, did I write that down somewhere? No, you just need to stamp that into your brain. A perpendicular line is the negative reciprocal. I thought that I wrote that somewhere in the lesson. It's probably going to come up somewhere. So you just need to memorize this information, and it makes sense. So the negative reciprocal of this right here, -4/3, is going to be +3/4. Now we know that the slope of the line we want is +3/4. What other piece of information do we need to know? We need to know the slope. This is m. We also need the y-intercept. How do we get the y-intercept? We don't have it. They didn't give it to us, but they did give us a point. So if we know a point on the line, we can just plug that in for x and y and solve for b. So let's plug in what we know. Instead of that m, we're going to put 3/4. Instead of x, we're going to use this point, x and y. So this is going to be -2. -2. Instead of the y, I'm going to put a 5. Just do the math, and you will solve for b. And I'm not going to take the time to do it because I know you know how to do that simple math. And the answer is 13/2. Now, that's not the final answer because I have to write the equation in y-intercept form now with what I know. Y is equal to mx, m is 3/4, plus b, which is 13/2. This is the final answer. Sweet, get it? All right, let's move on. Find the equations of lines A and B. All right, so they could give you a graph and make you figure out what the equation is. How would you do that? The same way, right? Let's start with A because A is going to be super easy. A is a horizontal line. Check it out. You remember that the equation for a horizontal line is just y is equal to some number. In this case, it's going to be equal to -2. because there's always an x, there's always a y. It doesn't matter where you move on the x, the y is going to be -2, and you end up on that line. Okay, so now all we need to do is find the equation for b. Let's do that. When you have a line like this, it's not horizontal, it's not vertical. We know that there are two variables. The two variables that we need to find are the m, the slope, and the b, the y-intercept. Now it doesn't show us where it crosses the y-axis, so that's a little tricky. So let's figure out the slope first. Remember that the slope is rise over run. How much does it go up and down versus how much does it run? So rise over run, how much does it rise? Let's find a place where we can sort of estimate 2 points. I would say one is here. The other one is here, where it's definitely on that corner, and that's going to be -6, 5. Okay, now that I have 2 points, it's basically like all the other equations that we did. Let's start with a triangle there and do rise over run. How much does it rise? So it goes from -5 up to 6. 5 plus 6 is 11. So the rise is 11. The run is how much? 1, 2, 3, 4, 5. 11 over 5. So that is the slope, 11 over 5. Is it positive or negative? It's positive because it's going uphill. So instead of that m, now we know that it's going to be 11 over 5. What about b? What about that point where it crosses the y-intercept? What we're going to do is the same as we did before. We take any one of these points, that -1, 6, or that -6, 5, plug that in for x and y. So let's do that for the -1, 6. So instead of x, I'm going to write -1. And instead of y, I'm going to write 6. And then I just solve for b. When I do that, I get b is equal to 41 over 5. And that's all that I need to know. I know the slope and I know the b, the y-intercept, right? So now I just write the equation and put in what I know.
I think I'm going to let you finish it from there, but the answer is 11 over 5x plus 41 over 5.
Rational denominators now. Now, we're going to take a number, just a regular number like 4. It's a regular counting number. And we're going to turn it into we're going to like torture it. We're going to make it a quotient, okay? When you divide it by different numbers, you're going to get an answer that's either going to be a decimal, like a straight number, an integer, or a decimal, or it could be like something that repeats with no end, right? So 4 over 1 would be just 4, okay? 4 over 2, obviously that's just 2. 4 over 3, actually, let's do a couple of different other examples. Let's forget the 4. Okay, we've had enough of the 4. Let's do 1 over 4. What do you get with that? You get 0.25. All of these numbers so far are rational numbers. That means if you have a number like this, it's rational. You can write it as if it's a ratio. Even a number that has repeating decimals forever can be written as a ratio. So for example, 13 over 3, if you put that into your calculator, it would be 4.33333 with a line over it, right? It goes on forever. And you can put an overbar to represent the pattern of digits that repeat. But if you have a pattern of digits that repeat, that can be expressed as a ratio, it turns out. For example, here's another one. What if you put this into your calculator? 111 divided by 99. You'll get a crazy answer, super fun. 1.121212. And that, turns out, goes on forever. The 1, 2 repeats. So if I want to write that in a different way, I could write it like this. 1, 2 with a bar over the 1 and the 2. then you know that the 1 and 2 repeat. Sorry about that hiccup. Okay, so that can be expressed as a ratio too. If it's a ratio, or it can be written as a fraction of integers or even something that repeats, that is called a rational number. That is allowed. It is rational. They don't need to go to the loony bin. These are all examples of rational numbers. This is just a straight decimal. That's fine. 0.4, yeah, that's fine. 0.4 is like the same as 4 out of 100, right? It's totally fine. Same with this. This could be written as a ratio, no problem. Same with this. These repeat forever, and there's a pattern to how it repeats, so that is okay and can be written as a ratio. This is like saying a third, right? This is also considered a rational number, so that's fine. So where do we get irrational numbers? Irrational numbers are the ones that are crazy and need to go to the loony bin. How do we know if it needs to go to the loony bin? Okay, here's one example. The number pi. The number pi, 3.14, we always call it that, but turns out that the numbers go on forever. Anytime you have a circle and you divide the circumference by the diameter, you get the same number, and it's 3.1415926535889. Turns out it goes on forever and it doesn't repeat. The circumference by any diameter will always do that. Even if you take the moon, the circumference of the moon divided by the diameter of the moon, yeah, pie in the sky. And it'll give you this crazy number that is irrational, and it goes on forever.
I was a little confused because you can express it as a fraction. That's how you get it, circumference divided by diameter. But it's not going to be a simple fraction.
We'll just leave it at that. Okay, there's another number that we're going to learn about later, which is called e. And e is the base for natural logarithms. And don't worry, you don't need to figure out what that is right now. But this is also another irrational number, 2.718 blah, 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 blah. Goes on forever, doesn't repeat. If you look in your book on page 77 at the bottom, it shows you the first 40 digits of that number. Okay, here's some more irrational numbers. If the square root, cube root, fourth root, or any counting number root is here, root, of a counting number, if it's not another counting number, like if it's not the square root of 49 is 7. Okay, so that's fine. That's a rational number. But if it's not just a counting number, then the root is going to end up being an irrational number. So all of these are going to be irrational numbers because it's not just a straight number for an answer. If it's not just a straight number, it goes to the loony bin. This is where we get a lot of our crazy, irrational numbers. Here's another custom that you're going to need to know for your assignments. It's customary to write rational denominators. So if it has a crazy number on the bottom of a ratio on the denominator, the answer is going to want you to fix that. So how would we fix this so that it doesn't have a square root 3 on the bottom? No problem. All we do is multiply the top and the bottom by square root 3, and that would give you an answer of 2 square root 3 over 3. And that's a better answer. It's just the customary way of writing that. Let's do another one where we have to change the denominator. This is called rationalizing the denominator. So this is one of our learning assignments, rationalizing the denominator. If you have an imaginary number on the bottom, that's going to be an irrational number because, of course, it's the square root of -1. So we got to get rid of that I on the denominator because that's not cool. All we have to do is multiply the top and the bottom by -I. What happens when we do that? We get -6I on top, and on the bottom, we have, on the bottom, I'm just going to bring this negative sign out and put -2 times I squared. And remember that I squared is the same as -1. -2 times -1 is just 2. So let's make that a 2. And then when I do the math, I get -3I for the answer. So that's a more proper way to do it. Now, there are more complicated things when you have something like this on the bottom and you want to simplify it so that you're rationalizing the denominator, so the denominator has no irrational numbers. There is a way to do this. So the way to do this, and I don't expect you to know it, this is why I'm teaching you how to do this. This is the way you get rid of irrational numbers on the bottom, and we'll just have to do one and then I'll try to explain why. What we're going to do is we're going to multiply the top and the bottom by what's called the conjugate of the denominator. You write the denominator the same, except you change the negative sign to a positive sign. If it's a positive, you're going to change it to a negative. Multiply everything by that. That's totally legal because that's just multiplying by 1. You're not changing anything. So let's see what happens when we multiply out this top part. You basically have to do first, outside, inside, last. And when you do that, you'll get 8 for the first. Outside, inside is going to be 2 square root 3 plus 12 square root 3 plus 9. We can combine this and just make it 14 square root 3. Bring this in. And then we can combine other like terms, so we can combine the 8 and the 9 and make it 17 plus 14 square root 3. So that's what we're going to get on the top. Now, what do we get on the bottom? Only look at the denominators now, and we're going to multiply this out, and we have to FOIL it. If we do first, it's going to be 4 minus 6 square root 3 plus 6 square root 3. And then for last, it's going to be minus 27. Now look what happened. These 6 square root 3's, the minus 6 square root 3 and the positive 6 square root 3, those basically cancel out. You can add them together to get 0. And that's why we used the conjugate of the denominator to multiply it by, because every time you do that, that middle term is going to cancel out. So all we're left with is 4 minus 27, and then you get negative 23. So that's the denominator. This is the numerator. Let's put it all together now. We're going to end up with 17 plus 14 square root 3 all over negative 23. That's the final answer. So we rationalized the denominator by doing it that way, okay? I know it's complicated. You just have to do some questions and you'll figure it out. Let's do another example. It's basically the same as the other one, just a little bit more complex. So pay lots of attention. First, we notice there's some i's here and there's some i's here. So they definitely want us to get rid of this I on the bottom. It just says to simplify this. So we're going to get rid of this I on the bottom. But first, we can simplify this top. Remember these things. I squared is negative 1. So when you have an I cubed like that, it's basically I times I. And that I squared is just negative 1. So you can multiply that by negative 1, make this a positive, and bam, that's how you simplify the top there. But you got to do that to this one too. I to the 5th I to the 5th is the same as this. So I have I squared twice. So this is a negative 1 times a negative 1, which is just 1, which just means all of this goes away. I can simplify it even further because now I've got a 1i plus a 2i, and that makes a 3i. That sounds like the beginning of a joke or something. What's 1i plus 2i? All right, now the bottom is not written in standard form. It's negative 2i plus 4. Usually we put those irrational or those imaginary numbers at the end. So I'm just going to change this to 4 minus 2y. It's the same thing, but that looks a little better, doesn't it? All right, now let's multiply the top and the bottom by the conjugate of the bottom, which is going to be 4 plus 2y. 4 plus 2y. Bam. It's just like multiplying it by 1. Doesn't even matter. It's not going to change it. Let's start with the numerator. I'm just going to put numerator here and FOIL this out. So first, and then we're going to do outside, and then we're going to do inside, and then we're going to multiply last. Okay, so when we do that, we get 8 plus 12i plus 4i plus 6i squared. We can simplify that, 12i plus 4i in the middle, and that's going to be 16i. And then we remember that I squared is just negative 1, so we can simplify that and just erase that and make it minus 6. And then we can combine like terms because 8 minus 6 is 2. 2 plus 16i. This is my numerator right here. Let's do the same thing to the denominator. Multiply that out. So the first term is going to be 16 plus outside 8i minus 8i plus 4i squared. Okay, and look what happened. Because we multiplied by the conjugate, we just get rid of those two terms. That makes nothing. 16 plus 4i squared, but I squared is just a negative 1. So it's 16, that should have been negative 4i squared. I messed up somewhere. Did you catch where I messed up, Addie? So if this I squared is just negative 1, now it's going to be 16 plus 4, which is just 20. And that is the denominator here that we just did. So the numerator is 2 plus 16i. The denominator is 20. Bam! Final answer right there. Got it? Got it. All right, there's more. I know. There's more. You have a quadratic equation that is in the form of these two equations. Check it out. This is called a square because it's like this is like one side of the table, and then you square it and you get the total area of the table. This is like one side of the table, you square it, you get the total area. Do you have no idea what's going on right now? Hang in there. Hang in there. It'll all come together. If you have an equation written in this format where you have something in parentheses, the whole thing is squared, and then you've got a number on the other side, this becomes easy to solve. And this is how. Let me show you. Super fun and easy to solve. We're going to square root both sides. When we do that, that gets rid of that square. So now all I have is x plus 1/2 is square root of, turns out, it could be plus or minus 3. And when I write that in a more standard form and I solve for x is negative 1/2 plus or minus square root 3. That's the final answer there. Easy to solve. Let's do that on this other side. What do? We square root both sides. When we do that, this whole thing cancels out. We get x minus 4 is equal to plus or minus square root 5. Bring the 4 to the other side. Have x is equal to 4 plus or minus square root 5. That's it. So when you see an equation and they want you to complete the square, they want you to get it into this format so you can go through that process. And once you get it into that format and do the math, you're going to notice some interesting things. X plus 3, the quantity squared. When you do the math on that, first, outside, inside, last, you're going to start to notice some patterns, and here they are. Here are the patterns you're going to start to notice. This is the answer that you get. The x is going to have a coefficient of 1. The coefficient for this middle x is just this guy doubled. It's this guy doubled. The last number is if you take half of this and then square it, you're going to get that last number. Let's see if that pattern holds true. What if you start out with this? You start out with x squared, the coefficient on that is 1. That second coefficient is this, but doubled. Do we double -5 and get -10? Yes. Now, what if you take half of this, that would be 5, -5, and square it, you get 25. Okay, so that pattern held true. Let's look at some other ones. What about this? This is a little more complicated. Here we have, coefficient here is just a 1, no problem. Now, what if you take this and you double it? -1/2, and you double it, you get -1. Ooh. Now, what if we take half of this -1, which would be -1/2, and then square it, you get a 4th. Ooh, the pattern is holding true. Okay, let's do this even more complicated one. Let's say you want to complete this square and you want to multiply that out. The coefficient on the x squared is just 1. The second coefficient is this guy, but doubled. Yes, it is. Now, what if you take this guy, you divide it in half, and you square it, multiply it by itself, you get 16/100, and that simplifies to that. Yeah, so true. Okay, now we're going to do something a little bit different. Here they're only going to give us a part of the equation. There's no plus a number like 3. So if we were to add plus a number to make this something that we could complete the square, how would we get that last number? Here the coefficient is 1. Here the coefficient is 3/5. What if we divide that in half? So 3/5 times a half is going to be 3/10. And then if we square it, we multiply it by itself. So you get 9/100. So if I add 9/100, now that's going to make it a perfect square for the quadratic equation. And I can go backwards from this perfect square, because this can also be written as x plus 3/10, the quantity squared. We just went backwards. So how did we get that 3/10? It was this before we squared it. Or you can think about it as it was half of this guy. 3/5 times a half. All right, now how would we use this in a problem? Because I'm just like adding weird things to equations, right? We're going to remember that the constant in the binomial, that means the x plus 3 quantity squared or whatever, this constant, that 3, is going to be half of the coefficient of x in the trinomial. The trinomial is the equation with 3 terms, x squared plus something, x plus something, whatever. Okay, let's remember that to try and solve this. They want us to solve this equation by completing the square. The first step is to write the equation in standard form. We got to put them in order. So we're going to do 3x squared minus x plus 5 equals 0. Now, we also have to have this be a coefficient of 1. So we're going to divide every term by 3. Even that 0, which is still going to be 0, but whatever. So now we'll get x squared, because this cancels out, minus 1/3 x plus 5/3 equals 0. Now, in our previous examples, we didn't have this 5/3 there. we had to figure out what would make that be a perfect square. So for now, we're going to move this to the other side. And in order to move it to the other side, we have to make this -5/3. Because, why? Because I just subtracted 5/3 from both sides of the equation. Now I'm going to try and complete this equation so that I can get a perfect square. How do I do that? I take this, I divide it in half times a half, and that gives me -1/6. And then I square that. So I multiply it by itself. And I get 1/36. That's the number that I put here. But I can't just add a plus 1/36 to one side of an equation. I've got to add it to both sides. It's not legal until I do it that way. Now it's legal. Now what can I change this to so that it's a perfect square? It's going to be x minus something with a perfect square. And it's going to be this number before we squared it, right? So it's -1/6. That negative was already there with that. So it's x minus 1/6 squared is equal to, you have to get common denominators before you solve that problem, but when you do that, it's going to be -59/36. Now, to simplify this, I square root both sides. That gets rid of this. And then I'm going to add that 1/6 to both sides to get rid of it here. And x is equal to that mess. Simplify this further because that bottom number is just going to be a 6. And what they put for their final answer is x is equal to 1/6. They just changed the order there, no big deal. Plus or minus the square root of 59/6 times I. Why times I? Because you've got a square root of a negative number. And that is solved. Whew. That was kind of awful. Thank you for hanging in there, Addie. Love ya. Bye.